Hello, in this video I want to show you how you can use normal distributions to find a probability, a proportion, or a percentage. So in this example we're going to talk about the medical college admissions test scores, or MCAT scores, and these are known to be normally distributed. So what that means is that they'll have a distribution something like this for the scores with a mean of 25. So that means mu is equal to 25, and sigma is then equal to 6.4, which is our population standard deviation and population mean. So our population mean is 25. Now the next step is that we should always draw 1, 2, and 3 standard deviations away from our mean in our normal distribution. So it's always good to draw the normal distribution so we can easily visualize proportions. So 1 standard deviation up from the mean is 31.4, 2 standard deviations up from the mean is 37.8, 3 up is 44.2, and 1 down is 18.6. And see, I'm simply just subtracting 6.4 from 25 to get there, and then subtract another 6.4, so 2 standard deviations down is 12.2, and then 3 standard deviations down is 5.8. So this is what the distribution of MCAT scores look like for the year 2010, and I want to find what proportion of students taking the MCAT had a score under 29. So I want to then shade in that region that I'm curious about. So this is about 29, and I want to find the area that falls below this. So something I know is that all the area below 25 is 50%, because that's our mean, and that's in the normal distribution. Always under the mean is 50% of our data, and so that gives me an idea that everything below 29% is going to have to be above 50%, something maybe around 60 or 70%. So this gives me a good eyeball account of what this proportion looks like. Now, if I want to then calculate this, I have to get a z-score. So I want to find the probability, or the proportion, that x is less than, so x being my MCAT scores, less than 29. This is equal to then the probability that my z-score is less than whatever I calculate from my z-score, which is equal to x minus mu over sigma, which in this case I'm going to plug in then the real values, the probability that z is less than 29 minus 25, all divided by my standard deviation of 6.4. And this then is equal to then what is the probability that z is less than 0.625, which I'm actually going to round this to 0.63 because I want to go to my z table to find the area that falls below a z-score of 0.63. So if I go over to my z table, the first thing I want to do is I want to look over here at the z's. And what I notice is that these are all negative values, so I need to go find the z-score that starts with 0.6. And I have found it. It is right here, so this is 0.6. And I'm going to scroll across until I find my hundredths place of 0.3. So this is a z-score of 0.63, and the proportion that falls below that is 0.73565. So 0.73565. Go back to my normal distribution, and so this means that the probability of x being less than 29 is 0.73565. So the proportion of students taking the MCAT that had a score under 29 is then going to be equal to 0.74. I'm just going to round it to 2 decimal places, or you could think of this as 74%. Okay, so for our next problem, we want to find the proportion of students that scored between 25 and 29. And so again, we should shade in this region. This is about the 29 area to about 25. So if we want to find this, what we find is we find the area that the probability that x is between 29 and 25. And so the way that we can find this is actually by subtracting the probability that x is less than 29 minus then the probability that x is less than 25. So what this looks like visually is essentially we are going to then take this entire area below 25 and just subtract off the blue part. So if we have all of 29 and we subtract off just the blue part here, then we'll get this then green shaded region that we want. That is then the area between 25 and 29. Well, this shouldn't be too hard because we've actually already calculated the area under 29. This was 0.73565, or as we rounded up here to 0.74. Well, we also already know the area that falls below 25. As we said before, this is always going to be then 50% because it falls below it's the exact mean. So this is 0.50. So to get the area that falls between, we simply just subtract these and we get a value of 0.23565, or in other words, about 0.24. So about 24% of the students scored between 25 and 29. Now for our last problem, we want to find the proportion of students that scored above a 29. So what does that look like? This is why it's important to always draw the distribution, is that this proportion above 29 is up here. So because this is a proportion that is less than or it's just right above our mean, we know that this is going to be less than 50%. So how can we find this? Well, actually, it's not too difficult because we already found the area that fell below 29. I'm just going to quickly shade that in here. We know this to be equal from the from the table 0.736 or 565. So 0.73565, that means that the area above this will simply just be the complement. So if we want to find the area above, we want to find the probability that x is greater than 29, then this is going to be equal to 1 minus the probability that x is less than 29. And why is it easier to find the complement? Well, this will be easier than when we actually calculate the z-score. So 1 minus the probability that z is less than 29 minus 25 over 6.4, which we already know to be 1 minus the probability of z being less than 0.63. We can easily then obtain this from our table because this gives us the area that falls below, which we know to be 1 minus 0.73565 from the table. This is something we already calculated. And then this will then give us a proportion of 0.26435. So that means that the area above 29 is going to be 0.26435, or approximately 0.26 for the proportion of students that scored above a 29 on the MCAT in 2010. Hopefully this video helped you understand how to use the standard normal table to then calculate z-scores along with proportions, probabilities, and percentages.